Hello students. Today we are going to solve few questions on time and distance. These questions are very important from the competitive examination point of view, also from the board examination point of view. Please visit our website www.examsnet.com to practice such questions. You can also download our app. The link is given in the description box. Let's begin with question number 1. A car is running at a speed of 108 km per hour. Find the distance covered by it in 15 seconds. So here speed of a car is given and time taken to cover some distance is given, right? So we need to find that distance, right? Here car is moving with the speed of 108 km per hour. Right? Speed is given. Speed is equal to. We all know the relation between speed, distance and time, right? Because speed is equal to distance divided by time. Distance divided by time. Here, speed of the car is 108 km per hour and it reaches its destination or it covers some distance d in 15 seconds. Right? Therefore, the distance covered by it, distance is equal to speed into time. Right? Speed into time. Here, speed of the car is 108 km per hour. Since the time is in terms of second, let us express the speed in terms of meter per second. Right? Convert this 108 km per hour, 108 km per hour is equal to, so 108 kilometer is nothing but 108 into 1000 meter, right? Divided by hour. Per hour means divided by 1 hour, right? 1 hour is 60 into 60 seconds, right? So which is 3600 seconds. Therefore, here we can cancel two zeros, right? So 36 into 3 is 108. So 10 into 3 is 30 meter per second. So 108 kilometer per hour is equal to 30 meter per second. So we'll write speed in terms of meter per second, which is 30 meter per second, right? Into time is 15 seconds, right? Car took 15 seconds to cover the distance d. Therefore, distance covered by it is 450 meters, right? The unit is meter, not kilometer, right? Since speed is in terms of meter, so distance is, speed is in terms of meter per second. So distance is in terms of meter. So car covered 450 meters distance in 15 seconds, right? Option A is the right answer. Question number 2. Mohan met with an accident after covering a distance of 30 km. He completed the remaining journey at 5/6 of the previous speed and reached his destination 36 minutes late. Had the accident take place 30 km further, it would have been only 30 minutes late. What is the normal speed at which Mohan drives? So students, it is given that, so he met with an accident after covering a distance of 30 km, right? We'll consider 30 km distance, right? And he covered that distance with the speed s. Let his speed be s km per hour, right? With this speed, he reached 30 km of distance, right? After that, he met with an accident and he covered the remaining part of his journey. So let x kilometer be the total distance, right? From one place to another place, from his starting point to the destination. This is the destination. Let x kilometer be the distance, right? So remaining part of his journey becomes x minus 30 kilometer, right? To cover this distance, so his speed was 5/6 of the previous speed. So 5/6 of s. With this speed, he covered the remaining distance, right? So next, and he reached his destination 36 minutes late. And he took t plus 36 minutes. If you consider t as the normal time to reach his destination with his normal speed, right, with the speed s, but he took t plus 36 minutes, t plus 36 minutes later, right? So, and in the second case, had the accident take place 30 kilometer further. So if the accident, right, takes place 30 kilometer further means at 60th kilometer, right? So if he covers 60 kilometer distance with speed s kilometer per hour, right? So after covering 60 kilometer distance, so he met with an accident, for example, right? Then it would have been only 30 minutes late. So he will take t plus 30 minutes of time, right? So if accident takes place 30 kilometer further, so it would have been only 30 minutes late. Time taken by him would have been 30 minutes extra, right? What is the normal speed at which Mohan drives? So after he met with an accident, his speed would be 5 by 6 of his normal speed, right? Even in the second case also, right? What is the remaining distance? Right here, if the total distance is x kilometer, remaining distance he covers is x minus 60 kilometer, right? So here the question is normal speed of Mohan. So we need to find value of his normal speed. Speed, yes. What is the normal speed, right? So for that, we'll consider the difference in the time taken by him, right? So in first case, it was a t plus 36 minute. In the second case, it is t plus 30 minute, right? Therefore, difference in time taken by him, right, is equal to, here it is t plus 36 minus t plus 30. This is the difference. That is 6 minutes of difference, right? So time can be expressed in terms of speed and distance. Since speed is distance by time, time is distance by speed, right? So in first case, time is distance by speed. So we can divide the distance covered by him in two parts. Before he met with the accident or after he met with the accident, right? So before he met with the accident, distance covered by him was 30 kilometer, right? With the speed, distance by speed is time. So with speed s, right? Plus after he met with the accident, distance covered by him was x minus 30 kilometer and the speed was 5 by 6 of s, right? Right? Minus, so when the time taken by him is t plus 30, right? Then it becomes distance by speed. So before he met with an accident, so distance by speed was 60 by s, right? Plus, so total time we are considering, so plus x minus 60 remaining distance by 5 by 6 of s, right? This gives difference in time, right? Difference in time taken by him. Here the first part is before accident. So second part is after accident. Also in the second time, right? So before accident and after accident, right? Now simplified. So difference in time is 6 minutes, right? Since distance is in terms of kilometer, we'll express time in terms of hour, right? So that we can express the speed in terms of kilometer per hour. 6 minutes is equal to 6 into 1 by 60 hour, right? 1 by 60 hour. Therefore, so simplification part, 30 by s plus, take this 6 to the numerator, it becomes 6 into x minus 30 divided by 5s minus 60s, right? Plus inside the bracket, it becomes 6 into x minus 60 by 5s. So we have 5s as the LCM. So here s into 5, so 30 into 5, 150, right? Plus 6x minus 180 minus, and the second part becomes 5s becomes the LCM. So 6 into 5, 60 into 5, it is 300 plus 6x minus 360. So Here in the first part, right? So minus 30 plus 6x. 6x, not s, 6x by 5s minus, here inside the bracket it becomes minus 60 plus 6x by 5s. So we can take 5s as LCM here. So numerators become, so minus 30 plus 6x. So minus of minus is plus 60 minus 6x. So minus 6x and minus 6x will get cancelled. So we have minus 30 plus 60 is plus 30 by 5s. So here we need value of s, right? Here the left hand side becomes 1 by 10. 1 by 10 is equal to so and so. Therefore, value of s is equal to 30 by 5 into 10. Sorry, 30 by 5 into 10 here, right? Therefore, it is 300 by 5, which is 60. So, s is speed, right? Which is in terms of kilometer per hour, right? So, speed of that man or speed of Mohan, initially he drives with the speed of 60 kilometer per hour, right? Value of s is 60 kilometer per hour. Option B is the right answer. Question 3. A car moving at 48 km per hour completes a journey in 10 hours. By how much the speed of this car should be increased so as to do this journey in 8 hours? Here, students, there are two methods to solve this type of question. So, first method is method 1. So, simplest method. Here, we'll consider the first condition in which car is moving with the speed of 48 km per hour, right? And it completes its journey in 10 hours, right? So in the second case, if the time taken by the car is 8 hours, right? In the second case, to complete the same distance d, if it takes less time, that which is 8 hours, so what should be the speed of the car, right? So that we need to consider. Here the question is, by how much the speed of this car should be increased. So we need to find increased speed. Find increased speed. For that, we need the speed of the car in the second case. Then only you can find increased speed, right? We all know that speed is equal to distance by time. Distance by time. That means speed is inversely proportional to time, right? So in first case, if we consider S1 as a speed of the car, S1 is distance by time, T1, right? So distance is same in both the cases. So in the second case, S2, speed of the car is same distance D by T2. Here T2 is second time, that is 8 hours, right? So we'll consider S1 by S2, right? S1 by S2 is D by T1 whole divided by D by T2, right? D by T1 whole divided by D by T2. Here denominator of the denominator is T2 will go to numerator. It becomes T2 by T1. D and D will get cancelled, right? So S1 by S2 becomes T2 by T1. This indicates speed is inversely proportional to time, right? Their respective, in two conditions, their respective speeds are inversely proportional to their time, right? So here S1, car is moving with the speed of 48 km per hour, right? S1 is 48. S2, in the second case, we need to find the speed, right? Is equal to T2. In the second case, right, 8 hours is the time. In the first case, 10 hours is the time. So it becomes 8 by 10, T2 by T1. We need S2. Speed in the second case is 48 into 10 by 8. So 8 into 6. So 6 into 10 is 60. 60 kilometer per hour is speed of the car in second case. But the question is, how much the speed of the car should be increased? So increased speed, we'll mention increased speed is original speed was 48 and the final speed in the second case it was 60. So increased speed is 60 minus 48. 48, which is 12 kilometer per hour is the increased speed, right? Option B is the right answer. So speed of the car should be increased by 12 kilometer per hour so that it takes less time, which is 8 hours in the second case, right? This is the first method, directly taking the ratios of the speeds in two different situations, right? This is the first method. In the second method, right? So car is moving with the speed of 48 kilometer per hour. The speed is given. Time is also given. Let us find the distance first, right? Distance is speed into time, which is 48 into 10 hours. So 480 kilometer is the distance, right? To cover the same distance, right? If the car takes 8 hours of time, so what is the speed? In the second case, case 2, right? If time is 8 hours, distance is 480 kilometer, what is the speed? So speed is distance by time, 480 by 8, which is 60 kilometer per hour is the distance. Sorry, the speed. Speed is 60 kilometer per hour. If the time is 8 hours. So what is increased speed here? Originally it was 48 kilometer per hour. In the second case it is 60 kilometer per hour. So increased speed is equal to 60 minus 48, which is 12 kilometer per hour. So the speed of the car should be increased by 12 kilometer per hour so that it takes less time, that is 8 hours, right? Option B is the right answer. Question number 4. Two trains start from P and Q respectively and travel towards each other at a speed of 50 km per hour and 40 km per hour respectively. By the time they meet, the first train has traveled 100 kilometers more than the second train. What is the distance between P and Q? So two trains, they start from two different places, P and Q, right? And travel towards each other means both the trains are moving in opposite direction, right? They travel towards each other in opposite directions. They travel at a speed of 50 and 40 kilometers per hour respectively. The first train is moving with the speed of 50 kilometer per hour and the second one is moving with the speed of 40 kilometer per hour. By the time they meet, that means we'll consider a point R somewhere here, point R or a place R. By the time they meet, the first train has traveled 100 kilometer more than the second one. So here, if you consider the distance covered by the second train as X kilometer by the time they meet, right? So that means at TR, right? We don't know what is the time taken by both the trains, right? So to reach that distance X, we don't know the time. Let us consider T as the time taken by both the trains to reach some distance or at point R, right? So here the distance traveled by the second train be X. By the time they meet, first train has traveled 100 kilometer more. That means distance traveled by the first train becomes X plus 100, right? Or you can consider the distances or the difference between the distances traveled by both the trains is 100 kilometers, right? So here, what is the distance between P and Q? We need the distance between the place P and Q, right? For that, we'll consider the speed, distance, and time relation, right? Since time is same here, so time taken by first train, right? So to be at place R is same as time taken by second train to be at the place R, right? Therefore, we'll consider time taken by first train, right, to be at R. This is for our better understanding. So first train to be at R is equal to time taken by second train. to be at certain place, which is R here, right? According to speed formula, speed is distance by time, right? So here we'll consider the distance traveled by first train, right? So when it is at R, right? Distance is speed into time, right? Since its speed is given, therefore we'll consider distance traveled by distance d1, let it be d1. d1 is equal to speed of first train is 50 km per hour into time taken by it is t, whereas d2 is speed into time, right? Speed into time. So what is the difference between these two distances here? d1 minus d2, distance traveled by first train minus distance traveled by second train is 100, which is already given, right? By the time they meet, the first train has traveled 100 kilometer more than the second one, right? Therefore, the difference in their distances is 100. Since distance d1 is 50t, d2 is 40t is equal to 100. Therefore, t into 10 is 100. Therefore, t is equal to 100 by 10 is 10 hours. 10 hours. Therefore, so both the trains take 10 hours time to meet one another, right? So here we need the distance between P and Q. So we'll consider distance between R and Q first, which is x kilometer. We'll find the value of x. Then we can easily find the value of x plus 100 and the total distance, right? Therefore, x is equal to distance between R and Q. RQ, x is equal to distance is speed into time, right? So here speed is with respect to second train. Since the distance x is covered by the second train here, so its respective speed is 40 km per hour and the time is 10 hours. So 40 into 10 hours. Therefore, it is 400 km. So RQ distance is 400. Therefore, PR distance is 400 plus 100, which is 500 kilometer, right? The distance between point R and point Q is 400 kilometer. And P to R is x plus 100, which is 500. Therefore, total distance PQ is 500 plus 400, right? Therefore, PQ, distance between PQ is 400 plus 500, which is 900 kilometer, right? Therefore, look at the options. Option A. Question number 5. A walks around a circular field at the rate of 1 round per hour, while B runs around at the rate of 6 rounds per hour. They start in the same direction from the same point at 7:30 a.m. They will first cross each other at. So students, here A walks around a circular field. Both A and B started from a same fixed point P at 7:30 a.m. Right? So we'll consider two persons A and B, right? So here A is moving with the speed of 1 round per hour, right? That means for every hour, so he can make 1 round, right? Therefore, 1 round per hour is A's speed, right? SA means speed of A, right? Speed of A. Whereas the speed of B is B runs around the same circular path, right, at a rate of 6 rounds per hour. 6 rounds per hour. Here, two bodies are moving in same direction, with two different speeds. When two bodies are moving in the same direction with two different speeds, we use the concept of relative speed. Relative speed. Right? So relative speed, when two bodies are moving in the same direction, difference in their speed is called relative speed. Right? Difference in their speed. Difference in their speed. For example, two bodies are moving with two different speed like 60 and 40 kilometer hours. right? Kilometer per hour, right? So their relative speed becomes 60 minus 40, which is 20 kilometers per hour. That means, so they appear to be moving with 20 kilometer per hour, which is a false one. That means false speed, right? But this speed is speed of one body with respect to another. That is called the term relative speed, right? Therefore, difference in their speed, when two bodies are moving with different speeds, so those bodies will be appearing that they are moving with the less speed, difference in their speed, right? So for example, this 20 kilometer speed, right? In the same manner, so come back to the question here, speed of A and speed of B are 1 and 6 rounds per hour, right? That means A is moving with the speed of 1 round per hour, B is moving with the speed of 6 rounds per hour, right? Then their relative speed becomes 6 minus 1, which is 5 rounds per hour. That means, so these bodies appear to be moving with 5 rounds per hour. That means, so they are meeting each other, right? So it is nothing but for us, for outsiders. So we feel that they are meeting each other. They are moving simultaneously, right? With 5 rounds per hour. That means for every hour or in 60 minutes, so two bodies can make 5 rounds, right? That means in 60 minutes, two bodies can make 5 rounds. 5 rounds. Therefore, for one round, right? So how many minutes they take? For one round, for 5 rounds, if they take 60 minutes, for one round, they take 60 by 5 minutes, right? 60 by 5 minutes, right? For 5 rounds, bodies take 60 minutes. Therefore, for one round, they take 60 by 5. That means 12 minutes, right? So that doesn't mean each body takes 12 minutes for one round, right? Since both are moving with different, that means speeds in the same direction, so they are meeting after 12 minutes, right? That means 7:30 to 12 means 7:30 plus 12 minutes is equal to, at 7:42 both the bodies meet each other. They first cross each other at 7:42 a.m., right? 7:42 a.m. Hence, option D is the right answer. Question number 6. A and B, who are 530 kilometers apart, starts moving towards each other at a speed of 55 km per hour and 25 km per hour respectively. A starts his journey an hour before B. How long will they take to cross each other? So here we'll consider A and B, right, who are 530 kilometers apart, right? So they start moving with the speeds 55 km per hour and 25 km per hour respectively. A starts his journey an hour before, right? So when they cross each other, we'll consider a point C somewhere here, right? When they cross each other, here at the point C, time taken by A, if you consider T as time taken by A to reach C, then time taken by B will be T minus 1 hour, right? If T is time taken by A to reach C, then time taken by B will be T minus 1, because A starts its journey an hour before B, right? Therefore, here what to be calculated? How long will they take to cross each other? To cross each other, what's the time taken by them? Exact time we cannot calculate here, right? Because A starts 1 hour early here, right? So what is the approximate time, right? So we need to calculate when they cross each other, what is the time taken by them, right? So for that, so we'll consider first time taken by A to reach C, right? So considering the speed of A and distance covered by A. What is the distance covered by A? For our convenience, we'll take D1 as distance covered by A, right, to reach C. D2 is distance covered by B to reach C, right? So here D1 is equal to, so speed is distance by time, right? D by T. Therefore, distance is speed into time. So D1 is speed of A into time taken by A. Speed of A is 55 km per hour into time is T here, right? Whereas D2, distance covered by B, is speed of B, which is given 25 km per hour into T minus 1. So, which is 25T minus 25, right? Is distance covered by B to reach C, right? So, we'll consider D1 plus D2. D1 plus D2. Why we are considering D1 plus D2? Because total distance is already given, right? D1 plus D2 is 55T plus 25T minus 25. D1 plus D2, total distance between A and B is 530 kilometer, right? Which is given. So 530 is equal to, so 80T minus 25. Therefore, ATT is 530 plus 25, right? Which is 555. Therefore, T is 555 by 80. So after simplification, you will get 6.9 something hours, right? So here T is time taken by A to reach C, right? Whereas time taken by B becomes T minus 1, 6.9 minus 1 it takes, right? 6.9 something minus 1 hour, which is 5.9 something, right? So here the question is, how long will they take to cross each other? To cross each other means at the point of contact C, how long they will take? So according to the option, so it is less than some value. Here the less value is 17 hours. They take less than 17 hours, right, to cross each other, right? So B takes 5.9 something hours, whereas A takes 6.9 something hours. So they take less than 17 hours to cross each other. So option B is the right answer. Question 7. Find the speed of a wheel in revolutions per second if a wheel takes 18,000 revolutions in 2 hours. Here, speed to be expressed in revolutions, dash revolutions per second. Revolutions per second, not in hours, right? Here, wheel takes 18,000 revolutions in 2 hours. Here, number of revolutions or the distance, if you consider in a circular path, number of revolutions are nothing but distance covered by that particular wheel, right? Here, revolutions or the distance is 18,000 revolutions and the time taken is 2 hours. So we'll express the time in terms of seconds. 2 hours is 2 into 60 into 60 seconds, right? 60 into 60 seconds. So 2 into 3,600 seconds, right? In this much seconds, 2 into 3,600 seconds. So wheel takes 18,000 revolutions. So what is speed then? Speed of the wheel is, here the distance by speed, right? Distance is 18,000 revolutions divided by time is 2 into 3,600. So you can cancel 2 zeros here. So 2 into 90 is 180. So we get 90 by 36. So 18 into 2, 18 into 5. So speed of the wheel is 5 by 2 revolutions per second. 5 by 2 in the sense, so 2.5 revolutions per 2.5 revolutions per second, right? 2.5. Hence option C is the right answer. Question number 8. The jogging track in a sports complex is, here is a small correction. It should be 726 meters, right? So the jogging track is 726 meters in circumference. Sanjay and his wife start from the same point and walk in opposite directions at 4.5 kilometer per hour and 3.75 kilometer per hour respectively. They will meet for the first time in. So again, this concept or this question is based on the concept of relative speed, right? So we'll consider a point from which Sanjay and his wife start jogging, right? In opposite direction. So Sanjay is moving with the speed of 4.5 kilometer per hour, right? If he is moving in clockwise direction, his wife will be moving in anti-clockwise direction. So with the speed 3.75 kilometer per hour. They will meet for the first time in, if two bodies moving in different directions with two different speeds, we use the concept of relative speed, right? So this relative speed gives their point of meeting, right? So relative speed is equal to, since two persons are moving in opposite direction, it is sum of their speeds. Sum of their speeds, right? So which is equal to, so 4.5 plus 3.75. Right? According to concept of speed, it is distance by time, right? So both of them cover 726 meters because the track circumference means this part, right? Part of, so circumference is 726 meters. So they cover 726 meters of distance, right? So time taken by them. So this gives their time of meeting, right? Therefore, here sum of their speeds is 8.25, right? 8.25 is equal to 726 by time t, right? Here speed is in terms of kilometer per hour and distance is in terms of meters. So look at the options. The options are in terms of minutes, right? So it is better to convert kilometer per hour into meter per minute, right? So 8.25 kilometer means, so into 1000 meter, right? Right? Per hour for 1 hour. So 1 hour means 60 minutes divided by 60, right? So which is in terms of meters per minute, right? Therefore, simplify it. So it can cancel 0 and 0. So it becomes 825 by 6, right? So which is equal to 726 by t. So we need value of t, right? T is equal to 726 into 6 divided by 825. So you will get 4356 by 825. So which is equal to 5.28. So T is in terms of, time is in terms of minutes, right? Hence option C is the right answer. Question number 9. Ajit goes at a speed of 47 km per hour. What is his speed in meter per second? Here, the given speed is in terms of kilometer per hour, right? So here it is 47 km per hour. Express this kilometer per hour in terms of meter per second. Very easy question. It is, since 47 kilometer is 47 into 1000 meter, right? 1000 meter. Per hour means divided by 1 hour, right? So 1 hour is 60 into 60 seconds, right? So 1 hour is 60 minutes and each minute is 60 seconds. So 1 hour is equal to 60 minutes into 60 seconds, right? Therefore, so 1 hour is 60 into 60 seconds. So here simplify it. So we 47 into 1000 by 3600, can cancel two zeros. 2 into 5 is 10, 2 into 18 is 36. So 47 into 5 by 18. Or you can directly take a number which is in terms of kilometer per hour is equal to the same number into 5 by 18. Right? If you want to convert this kilometer per hour into meter per second, multiply that particular number by 5 by 18. Right? Otherwise, you have to write 1 kilometer is equal to 1000 meter, then divided by per hour means 60 into 60 seconds, right? So Here on simplification, you will get 7 into 5, 35, 5 into 4, 20, 20 plus 2, 23, 235 by 18, right? So 18 into 1, 18 into 3 is 54, then 13.0, then 18 into 5, yes? Yes, 13.05 is the answer, which is approximately equal to 13 meter per second, right? Nearby value is 13 meter per second. Therefore, 47 kilometer per hour. His speed in terms of meter per second is 13 meter per second, right? Hence, option D is the right answer. Question number 10. A bike was stolen at 2 a.m. and the thief drove it at 20 km per hour. Police start chasing him after 24 minutes at a speed of 25 km per hour. Thief will be caught at. So we'll consider position of thief somewhere here, right? Bike was stolen by him at 2 a.m. 2 a.m. Thief drove the bike at 20 km per hour speed, right? Police starts chasing him after 24 minutes. So after thief starts the bike, after he's stolen the bike, he starts chasing him after 24 minutes. If, for example, so we'll consider some other point P somewhere here where police caught the thief, right? At this point, police caught the thief, right? For that, here, if thief takes the time T minutes to reach point P, police takes only T minus 24 minutes. 24 minutes time to reach the point P. Right? Are you getting my point? Because police starts chasing him after 24 minutes. After he stolen the bike, right? So if he stolen the bike at 2 a.m. after 24 minutes means, so 2 a.m. at 24 minutes. At that time, police starts chasing him, right? Therefore, time taken by police will be T minus 24 minutes, whereas time taken by thief to reach point P is T minutes, right? So that both of them covered same distance is same here, right? Here what is asked in the question? So thief will be caught at what time thief will be caught? For that we need to consider time taken by thief and police to reach point P. Then only we can easily find the time, right? So at what time thief will be caught, right? For that, since distance is same, right? Distance is same here. Distance covered by thief and police is same. Therefore, so distance covered by thief, distance covered by thief is equal to, so distance covered by police, covered by police. How do you find the distance based on speed and time? By the formula, speed is equal to distance by time, right? Distance by time. So distance is speed into time. So distance covered by thief is, so speed of thief, which is 20 kilometer per hour, into time taken by thief is T. To reach point P, he takes T minutes of time, right? Right? So here 20 kilometer per hour is, yes, here the time is in terms of hour, whereas time taken by him is in terms of minutes. So divided by 60 gives kilometer per minute, right? 20 kilometer per minute. So here distance covered by police is 25 kilometer per hour, right? Divided by 60 gives 25 by 60 kilometer per minute, right? Into time taken by police is T minus 24 minutes, right? Here this time is in terms of minutes. So distance is kilometer divided by minute, per minute. Simplify it, since we can cancel 60 and 60. So 20t is equal to 25t minus 25 into 24, right? Therefore, 25t minus 20t is equal to 25 into 24, right? So 5t is equal to 25 into 24. So value of t is 25 into 24 divided by 5. So 5 into 5, 24 into 5 is 120. So in terms of minutes. So time taken by whom? Time taken by thief to reach point P is 120 minutes. Right? So 2 a.m. to 120 minutes. After 2 a.m. 120 minutes is equal to 2 hours. Right? Therefore, thief reaches the point, or thief will be caught by the police at 4 a.m. 2 a.m. plus 2 hours becomes 4 a.m. Therefore, thief will be caught. Right? Thief will be caught at 4 a.m. Question number 11. A cyclist riding a bicycle in a fog crossed a pedestrian who was walking in the same direction at the rate of 1.5 km per hour. If the pedestrian could see the cyclist for 4 minutes and if the cyclist was visible to him up to a distance of 0.4 km, what was the speed of the cyclist? Here, a pedestrian is walking. Pedestrian will consider the position of the pedestrian somewhere here, who is walking at a speed of 1.5 kilometer per hour, who could see a cyclist, right, and who could see the cyclist for 4 minutes. We'll consider the position of cyclist somewhere here, who is moving, and you could see the pedestrian could see the cyclist for 4 minutes up to a distance of 0.4 kilometer. Here we need to find speed of the cyclist. Here to find speed of the cyclist, we'll consider the direction of motion of both pedestrian and cyclist. Both the persons are moving in the same direction. Therefore, we use the term relative speed. What is relative speed? Speed of one object with respect to another is called relative speed in general terms, right? Here, since we need to find the speed of the cyclist, so it is nothing but speed of the cyclist with respect to pedestrian, right? With respect to pedestrian. When two bodies are moving in the same direction, two persons are moving in the same direction, then difference in their speed is considered as relative speed. When two objects are moving in opposite direction, then sum of their speeds is considered as relative speed, right? Here in this particular case, two bodies or two persons are moving in the same direction. Therefore, difference in their speed is considered as relative speed. So, speed of cyclist with respect to pedestrian is called relative speed, right? So, we'll consider x as speed of cyclist because we need to find speed of the cyclist, right? So, let x kilometer per hour be the speed of cyclist. Right? Therefore, with respect to another object is pedestrian, right? Therefore, difference in their speed will consider relative speed is equal to. So, in general terms, speed is always distance by time, right? Distance by time. Since relative speed is difference in their speed, so speed of the cyclist x minus speed of pedestrian is 1.5 km per hour is equal to, here distance is distance covered by cyclist, not the pedestrian, right? Because we are going to find the speed of the cyclist, right? So distance is 0.4 km, time is 4 minutes. Since the time is in terms of hour, in case of speed of pedestrian, it is 1.5 km per hour. So we'll express time taken by cyclist also in terms of hour. So 4 minutes divided by 60 becomes into 60 in the numerator part, right? 4 by 60 hour it becomes. So this 60 goes to numerator here. So on simplification, you will get x minus 1.5 is equal to 4 by 4 is 0.1 into 66, right? The unit is here, we'll consider later. X is equal to, we need the value of x. So it is 7.5. Here x is speed of the cyclist, right? So 7.5 kilometer per hour, right? Therefore, option C is the right answer. Students, here we are using the simple concept of relative speed since two persons are moving in the same direction and both of them are moving, right? So, relative speed is speed of one person with respect to another, right? Here, speed of cyclist should be calculated. Therefore, speed of cyclist with respect to pedestrian is called relative speed, which is difference in their speed. So, x minus 1.5 is, so using general formula, it is distance by time. So, distance covered by cyclist, right? By time taken by him. So, on simplification, you will get 7.5 kilometer per hour as the speed of cyclist. Hence, option C is the right answer. Students, if you want to practice such questions on time and distance, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question number 12. Points A and B are 70 km apart on a highway. A car starts from A and another from B at the same time. If they travel in the same direction, they meet in 7 hours. But if they travel towards each other, they meet in 1 hour. Find the speed of the two cars. So students, we'll consider 2 points A and B, right, which are 70 km apart, right? So a car from point A, right? So travels towards B, and also car from point B. So it also travels in the same direction, right? Both the cars are moving in the same direction, right? So let speed of car A be x kilometer per hour. Speed of car B is y kilometer per hour, right? So here, if they are traveling in the same direction, they meet in 7 hours. That means B takes 7 hours of time to meet A at some point. Let the point be somewhere here. A also takes 7 hours of time to meet B, right? So at this point, both A and B will meet, right? Here, the question is speed of the two cars. So we need to find value of X and Y, right? We know that speed can be expressed in terms of distance and time. We use that concept. And it is also given that if they travel towards each other, so we'll consider same 2 points A and B, which are 70 kilometers apart, right? If they travel towards each other, B is traveling towards A is traveling towards B. They meet in 1 hour. They take 1 hour of time. Each car takes 1 hour of time to meet each other, right? And the distance between two cars is 70 kilometer in the second case, right? Let their speeds be x kilometer per hour and y kilometer per hour respectively, right? Here, two cars are moving with two different speeds. In first case, both the cars are moving in the same direction, right? In the same direction. In the second case, both the cars are moving in different directions, opposite to each other, right? Different directions, right? Here we use the concept of relative speed. So using that this concept, relative speed concept, we are going to find speeds of two cars, right? So for that, let us consider distance between them. In first case, right? Focus on first case. Distance between two places A and B is 70 kilometer. So this distance can be expressed in terms of speed and time, right? So here, in first case, distance covered by A to meet B is, so distance covered by A, right? So in 7 hours, or to meet B, right? In 7 hours is, so distance is speed into time, right? Therefore, speed of car A is x and it takes 7 hours of time, right? So distance covered by A in 7 hours is speed into time, 7x. Whereas distance covered by B in 7 hours, which is equal to, yes, 7 into y. 7 into y. Since both are moving in same direction, relative speed, their relative speed is difference in their speeds, which is x minus y, right? X minus y. And also the distance from A to B, which is 70 kilometer, right? Which is AP distance covered by A minus distance covered by B, right? Therefore, here AB distance is equal to distance covered by A to meet B, which is 7x, right? Minus 7y, right? So what is AB, which is 70 kilometer, right? Distance between AB, 70 kilometer, 7 into x minus y, x minus y. Since x minus y is relative speed, so we'll write x minus y is 70 by 7, which is 10. Consider this as equation 1, right? Now, consider the second case, right? In the second case, both the cars are moving in different directions, right? Therefore, we use the concept of relative speed, in which sum of their speed is relative speed, right? So, relative speed is equal to x plus y. Why it is x plus y? We'll consider, right? So, distance traveled by first car in 1 hour plus distance traveled by second car in 1 hour becomes total distance, because both the cars meet at some point P somewhere here, so that the total distance traveled by them is distance between them, right? So, total distance, or separately you can consider, so distance traveled by A plus distance traveled by B, I'll take it as dB, is equal to 70 kilometers, right? So distance can be expressed in terms of speed and time, right? Speed into time, it is distance. Speed is x, so A takes 1 hour of time, right? So therefore it is x into 1 plus speed of B is y into 1, right? Is equal to 70. Total distance is 70. So x plus y is equal to 70. Consider this as equation 2. So from equation 1 and 2, simultaneous linear equations. So we'll add equation 1 and 2. You will get 2x is equal to 80. So value of x becomes 40. Right? Therefore, y is equal to substitute value of x in any of the equations. So 1 or 2. So here equation 2 becomes, substitute the value of x in equation 2, y becomes 70 minus 40, which is 30. So x is the speed of one car, first car, which is 40 km per hour, whereas y is speed of another car, which is 30 km per hour, right? So now option speed of the two cars is 40 and 30, right? Option B is the right answer. Question 13. A man completes a journey in 5 hours. The first half of the journey is traveled at the speed of 20 km per hour, while the second half is traveled at the speed of 10 km per hour. What is the average speed for the whole journey? Here, first half of the journey, here total time taken is 5 hours, right? In that first half of the journey means the first half of the distance. If d is the total distance, right, d by 2 distance has been covered, right, with the speed of 20 km per hour, whereas the remaining d by 2 distance, remaining d by 2 kilometer distance has been covered at the speed of 10 km per hour. Right? So when equal distances have been covered by the same person with two different speeds, 20 and 10 km per hour, right? In that case, average speed is equal to average speed of the journey, or average speed in the journey, or average speed of a man is equal to, right? Since two different speeds are given, so we'll consider these as x and y. Right? Then average speed becomes twice the product of the speeds given divided by sum of the two speeds, x plus y, 2xy by x plus y. Right? This formula is applicable when the same distance has been covered in a journey. That means two times the same distance has been covered, or the whole journey distance when it is divided into two equal parts, right? When same distance has been covered with two different speeds, S1 and S2, two different speeds, or x and y, then average speed is equal to 2 times xy by x plus y, right? So apply the same formula and substitute the values here. X is 20 kilometer per hour, y is 10 kilometer per hour. So 2 into 20 into 10 divided by 20 plus 10. And so it is 400 by 30, right? So which is equal to 40 by 3 kilometer per hour. So average speed of the given man is, right, 40 by 3 kilometer per hour, option B. Question 14. A person travels equal distances with speeds of 3 km per hour, 4 km per hour and 5 km per hour and takes a total time of 47 minutes. What is the total distance in kilometer? So he travels equal distances, right, in three different speeds, right? So here we'll consider equal distances as x, x and x, right? With three different speeds, 3 km per hour, 4 km per hour and 5 km per hour. And the total time taken is, so T is 47 minutes. So which is equal to 47 into 1 by 60 hours. Here we need to find the total distance in kilometer, right? So to find the total distance, so we'll consider the individual distances, x, x and x, right? If you find individual distances, so x plus x plus x gives the total distance, right? So how individual distance depends on the speed and the total time given, right? So we'll consider individual time here in first part of the journey to cover, that is x distance. So what is the time taken by that person? So we'll consider it as T1. T1 is equal to, so we know that speed is always distance by time. Distance by time. Therefore, time is distance by speed. So here in first part of the journey, distance is x kilometers, right? X kilometers. And the speed is 3 km per hour. Whereas T2 is again the same distance, right, has been traveled in the second part, x kilometer by 4, whereas T3 is x by 5 in terms of hours, right? X by 4 hours, x by 3 hours. We'll consider T1 plus T2 plus T3, right? So here the total time is already given. T1 plus T2 plus T3 is equal to x by 3 plus x by 4 plus x by 5. Right? Since LCM is 60, numerator becomes 20x plus 15x plus 12x. Right? T1 plus T2 plus T3 is the total time taken by the person, which is 47 into 1 by 60 hours is equal to, so 20 plus 15, 35 plus 12 is 47x by 60. Therefore, x is equal to, here 47 by 60, 47 by 60 will get cancelled. So x is equal to 1 kilometer. So in first part of the journey, person travels 1 kilometer distance. Here the question is, what is the total distance in kilometer, right? So total distance is equal to, so there are three equal parts in the journey, right? So 1 kilometer in first part and again 1 kilometer plus 1 kilometer. So totally person traveled 3 kilometers distance, right? In 47 minutes. Hence option C is the right answer. Question number 15. Era and Anna traveled the same distance at the rate of 80 km and 100 km per hour, respectively. If Era takes half an hour longer than Anna, the distance traveled by Anna is. So here we'll consider the speeds of Era and Anna. So 80 km per hour and 100 kilometer per hour, and both of them travel the same distance. So let D be the distance traveled by them, right? Both of them travel the same distance. Era takes half an hour longer than Anna. The distance traveled by Anna is. So if you consider T1 as era, time taken by Era, right? So here, this is Era's case, Anna's case, right? T1 is the time taken by Era. Time is always distance by speed, right? So distance by speed is time, right? So here distance is D, speed is 80, right? Whereas Anna takes T2 time. So here the distance is D, speed is 100 kilometer per hour. And given that Ara takes half an hour longer than Anna, that means T1 minus T2. Time taken by Ara is greater. So T1 minus T2, difference in their timings is half an hour, 1 by 2. So which is D by 80 minus D by 100 is 1 by 2. Since LCM is 400, I think, right? LCM is 400. Hence 80 into 5 is 400. 100 into 4. Am I right? Yes. Is equal to half. Hence D is equal to 400 by 2, which is 200. Hence distance covered by them is 200 kilometers. Right? What is the question? Distance traveled by Anna. Both of them traveled the same distance. Therefore, distance traveled by them is 200 kilometers. Option D. Question 16. A motorist covers a certain distance at an average speed of 48 km per hour in 45 minutes. What speed in kilometer per hour he must maintain to cover the same distance in 30 minutes? So here, if you consider D as distance covered by motorist, right? His speed is 48 km per hour and he takes 45 minutes to cover that distance D, right? In order to cover the same distance, what speed he must maintain, right? So that he can cover the same distance in 30 minutes, in only 30 minutes, right? So here the time in the second case is 30 minutes. What should be the speed provided the distance covered by him should be same, right? Therefore, we are using the formula distance is equal to speed into time, right? Speed into time. In first case, distance D is equal to 48 into 45 minutes. So in terms of R, it is divided by 60, right? So this much kilometer is distance traveled by him, right? So if distance is same, what should be the speed if the time is 30 minutes? Therefore, we can equate this distance. Therefore, 48 into 45 by 60. To cover the same distance, the speed should be speed into the time is 30 minutes, right? In terms of hour, it is 30 by 60 hours. Speed into time is equal to distance. Here, in the second case, what should be the speed? Therefore, speed is equal to, since we can cancel 60 and 60, speed is equal to 48 into 45 by 30. So 15 into 2, 15 into 3, 2 into 24. So 24 into 3 is 72 kilometer per hour is his new speed, right? Should be 72 kilometer per hour so that he can cover the same distance in 30 minutes, right? Hence, he should maintain the speed, right, at 72 kilometer per hour, right? Question number 17. Including stoppages, the speed of a school bus is 56 km per hour and excluding stoppages, the speed is 63 km per hour. Find the time spent on stoppages. So students will consider 2 points A and B, right? So school to home, for example. So let the distance be X kilometer, right? So to travel from home to school or school to home, right? Including stoppages, speed of the school bus is 56 km per hour. So, including stoppages, so speed, so we'll consider it as S1. Speed of the school bus is 56 km per hour, right? And excluding stoppages without any stop, school bus travels with the speed of 63 km per hour, right? Find the time spent on stoppages, right? What is the time spent on stoppages? Time spent on stoppages. For that, so we'll consider time spent by school bus, including stoppages and excluding stoppages, right? So here we'll consider first case, time spent including stoppages. Since distance is x, so distance by speed gives time, right? So distance from home to school by speed of the bus. So including stoppages, speed of the bus is 56 km per hour and the distance to be traveled here is x. So time spent, let it be T1, time spent including stoppages is x by 56 hours. X by 56 hours. Whereas, so time spent excluding stoppages. Here is, let it be T2, again distance by time, same distance to be covered, but with different speed, which is 63 km per hour. So therefore, x by 63 hour is time spent excluding stoppages. So we'll consider these as equation 1 and 2. What is to be calculated here? Find time spent on stoppages, right? So for that, we need the relation between T1 and T2, right? Including stoppages time and excluding stoppages relation. So how they are related, in what ratio they are related? For that, so we'll divide one equation by another one. So equation 1 divided by 2 gives, or equation 2 divided by 1 gives, right? Therefore, T1 divided by T2 gives x by 56 whole divided by x by 63. So 63 goes to numerator, it becomes 63 by 56. Here x and x will get cancelled, right? So 7 into 9, 7 into 8. So T1 and T2 are in the ratio 9:8. That means if time taken including stoppages is 9 hours, if T1 is 9 hours, then time taken excluding stoppages becomes only 8 hours, right? So if T1 is 9 hours, including stoppages, it is including stoppages. This is excluding. So excluding stoppages, bus takes 8 hours of time, right? Therefore, the question is find time spent on stoppages. That means this difference in time. So the extra time is spent on stoppages, right? Therefore, time spent on stoppages. Time spent on stoppages is equal to, so including stoppages it was 9 hours minus excluding stoppages it was only 8 hours. So 1 hour of time was spent on stoppages, right? 1 hour. Hence, option A is the right answer. Question number 18. The speed of a car increases by 2 km after every 1 hour. If the distance traveled in first 1 hour was 35 kilometers, the total distance traveled in 12 hours is. So here students will consider speed of a car, right, in first hour, right? So it, and in the second hour it increases by 2 kilometers. So here, so in first hour the distance traveled by the car is 35 kilometer in first hour. Therefore, speed becomes, if you consider S1 as speed of the car, distance by time duration is only 1 hour. So it becomes 35 kilometer per hour, right? And it is increased by 2 kilometer. In the next hour means S2 becomes 35 plus 2 is 37 kilometer per hour. This will be the speed in the next 1 hour, right? In the next 1 hour duration, the speed increased by 2 kilometer per hour. That is 39, right? 39 kilometer per hour, right? So here the total distance traveled in 12 hours, right? So in 12 hours, so last 12th hour duration, right? So the distance traveled by the car. So for that, in each case, we have to find distance traveled by the car. In each case means in each time duration, 1 hour time duration, what is the distance traveled by the car, right? Because this distance depends on the speed of the car, right? Therefore, if the speed is increased, distance also automatically it will increase, right? Therefore, in the 12th hour also, we need to find distance traveled by the car, right? So depending on the values, these distance values, we need to find the total distance traveled by the car, right? So since the time duration is same, in each case it is 1 hour, right? In each case, so for every 1 hour, the speed of the car changes, right? Therefore, the respective distances become speed into time, right? Since speed is equal to distance by time, distance by time. So in each 1 hour duration, the distances are 35 kilometers, which is speed into time. And in the next 1 hour duration, it is speed into time is same. It is 1 hour. So which is 37 kilometers. Next, it becomes 39 kilometers. So on up to. So in the 12th hour duration, here time duration is 1 hour. 1 hour. So what is the distance? We need to find that, right? So what is the distance? For that, we'll consider all the distances, different distances traveled, in every 1 hour, 1 hour duration are 35 kilometers, right? 37, 39, then it comes 41 and so on, right? These numbers are in arithmetic progression, right? There is a common difference which is 2, right? So we'll consider AN. So in arithmetic progression, so the general format is A1, A2, A3, so on up to AN. First, we need to find AN. AN in the sense here, distance traveled in 12th hour duration, right? Which is D12. We all know that AN is A plus N minus 1 into D. Here AN is nth term, right? This is nth term. Nth term. Here, so instead of taking nth term, we need the total distance traveled in 12 hours. So in 12 hours means there are 12 different 1 hour durations. Here, number of terms are 12. So in this progression, n is equal to 12. We need total distance. Total distance means sum of these individual distances. So which is equal to Sn. It is not An. Here An represents nth term or 12th distance. Right? Here we need total distance. So it is Sn. By the formula, Sn is n by 2 into 2a plus n minus 1 into d. Here n is 12 and the common difference d is 2, right? Difference between two consecutive terms, right? Whereas a is the first term which is 35, right? Therefore, sum of all these distances is equal to 12 by 2 into 2 times 35 plus n is 12 minus 1 into common difference is 2. Simplify it, 6 into 70 plus 11 into 2 is 22. Therefore, we have 6 into 92, right? So 12, then 54 plus 1, 55. So 552 kilometers is the total distance traveled by the car, right? 552 kilometers. Option B is the right answer. Question 19. Raman drove from home to a neighboring town at a speed of 50 km per hour, and on his returning journey he drove at a speed of 45 km per hour and also took an hour longer to reach home. What distance did he cover each way? So right, we'll consider two places A and B, right? Two places A and B. Raman drove from home to neighboring town, right? A to B at a speed of 50 km per hour. Right? While coming back, he drove at a speed of 45 km per hour. Here, what distance did he cover each way? Since distance is same from A to B, from home to neighboring town, distance is same, right? So distance is same. Right? So what distance did he cover each way? We need to find, right? Since distance is same and time taken by him, we have to consider here, if T is time taken by him to reach B from A. From A to B, if he takes T time, right? Or T hours of time, right? From B to A, he took an hour longer. That means from B to A, he took T plus 1 hour. T plus 1 hour of time. Or in other words, you can say the difference between time taken by him is 1 hour. Right? If you consider T1 as time taken by him in first case and T2 as time taken by him in the second case, then here T2 is greater than T1, right? In the second case, he takes more time, right? So T2 minus T1 is equal to 1 hour. Right? While coming back, he took more time, right? T2 minus T1 is equal to 1 hour. What is T2 in terms of speed and distance? We all know that speed is equal to distance by time, right? Distance by time. Therefore, time taken by him is equal to distance by speed. Keeping this in our mind, so here T2 in the second case, distance covered by him is same, which is D, by speed. His speed was 45 km per hour in the second case. That means while coming back, minus T1 is same distance by his speed was 50 km per hour, right? Is equal to 1 hour, right? Since the LCM is, you can directly take the product of 45 and 50 as the LCM, and the numerator becomes 50D minus 45D is equal to 1, right? So we have 5D is equal to 45 into 50. Hence, D is equal to 45 into 50 by 5. So 5 into 10 is 50. Therefore, it is 450 kilometers, right? Therefore, the answer is the distance he covered each way, not total distance. Each way he covered 450 kilometer distance, right? Option C is the right answer. Question 20. A train travels at an average of 50 miles per hour for 2.5 hours and then travels at a speed of 70 miles per hour for 1.5 hours. Find the distance traveled by the train in entire 4 hours. Here, for the first 2.5 hours, if you consider the time duration as first 2.5 hours, right? So what is the distance traveled by the train? Let it be D1, right? So in the first 2.5 hours, train is traveling with the speed of 50 miles per hour, right? And in the next 1.5 hours, it traveled with the speed of 70 miles per hour, right? With that speed, the train covers D2 distance, right? Here the question is distance traveled by the train in entire 4 hours means what is the total distance traveled by it? right? Total distance. So which is nothing but d1 plus d2, right? First distance or distance traveled by it in first 2.5 hours plus distance traveled by it in the next 1.5 hours, right? Therefore, d1 is equal to, we all know that speed is equal to distance by time. Therefore, distance is equal to speed into time. So speed of the train in first 2.5 hours is 50 miles into time is 2.5. Hence it is 50 into 5 by 2. So 2 into 25 is 50. So 25 into 5 is 125 miles is distance traveled by the train in first 2.5 hours. 125 miles. Whereas in the next 1.5 hours, D2 is speed, which is 70 miles into time, 1.5 hours. So 70 into 3 by 2, right? So 35 into 3 is 105 miles is the distance traveled by the train in the next 1.5 hours, right? 105 miles. Here the question is distance traveled by the train in entire 4 hours. That means total distance is d1 plus d2, right? 125 plus 105 is equal to 230 miles. 230 miles is the total distance traveled by the train. Hence, option A is the right answer. Students, if you want to practice such questions on time and distance, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 21. In a flight of 600 km, an aircraft was slowed down due to bad weather. Its average speed for the trip was reduced by 200 km per hour and time of flight increased by 30 minutes. What is the duration of a flight? So in a flight of 600 kilometers, that means here the distance, total distance, if you consider d is equal to 600 kilometer, right? This distance need to be covered is 600 kilometer. So an aircraft was slowed down due to bad weather. So the average speed was reduced by 200 kilometer per hour. Here the reduced speed, if you consider ideal speed as x kilometer per hour, speed is equal to x kilometer per hour. In reduced condition, reduced speed becomes x minus 200 kilometer per hour, right? X minus 200 kilometer per hour, and time of flight increased by 30 minutes. If you consider time as t hours in ideal condition, so due to bad weather, the time of the flight increased by 30 minutes. That means it becomes t plus 30 minutes, means t plus half an hour. T plus half an hour, or the difference between the times is equal to half an hour, right? What is the duration of the flight? So in an ideal condition, what is the duration? What is the value of t here, right? So either you can consider difference in the time durations, right? If you consider t1 and t2 as time taken by the flight in two different situations. In ideal condition, let it be t1, and due to bad weather condition, the time taken by the flight be t2, then the difference between the time, because due to bad weather flight takes more time, therefore it becomes t2 minus t1 is equal to 30 minutes or half an hour, right? Either you can take this method or take the case of speed, because speed also reduced by 200 kilometer due to bad weather, right? Difference in the speed. There are two methods. First one is by taking difference in time duration. Second method is difference in speed or change in speed, right? So any method you can consider. We'll consider change in speed. So the speed was reduced by 200 kilometer per hour, right? So original speed was x kilometer per hour. So difference in speed is equal to 200 kilometer per hour, right? So original speed x, right, minus original speed x minus next speed is x minus 200, right? So it is 200. So let us express original speed in terms of time and distance. Since speed is distance by time, keeping that formula in our mind. So difference in speed. So the distance is 600 kilometer. Distance by time. Here the time according to our assumption it is t. Even you can consider t1. So 600 by t is the speed in first case minus 600 by t plus half an hour, right? Original time plus half an hour gives the next speed, right? Due to bad weather, the speed becomes 600 by t plus half is equal to 200, right? Which gives difference in the speed of the flight. So on simplification, you will get t into t plus half as the LCM, and the numerator becomes 600t plus 600 into half is 300 minus 600t is equal to 200t into t plus half. So we can cancel 600t and 600t. So we have, so this t into t plus half will go to RHS part. So 300 is equal to 200 t square plus 200 t square plus 200 t into half, which is 100 t, right? So we have 200 t square plus 100 t minus 300 is equal to 0. So we'll take 100 as common here. So we have 2t square plus t minus 3 is equal to 0, right? A quadratic equation. So find the value of t by splitting the middle term. Since the coefficient of t square is 2 and the last term is minus 3, their product becomes 2 into minus 3 is minus 6. Therefore, split the middle term in such a way that product of the coefficients of the middle terms should be minus 6 and their sum should be 1, which is coefficient of t. Therefore, middle term becomes 2t square plus 3t minus 2t. Right? So that plus 3 minus 2 becomes minus 6, which is the product of coefficient of t square and the last term. Right? So minus last term is equal to 0. So take first two terms where t is common and the remaining terms are 2t plus 3. And in the last two terms minus 1 is common. We have 2t plus 3 is equal to 0. Therefore, we have 2t plus 3 is equal to 0, right? Or t minus 1 is equal to 0. So here t becomes minus 3 by 2. Here time cannot be negative. Therefore, t is equal to 1. So which is the right answer here? 1 hour. Right? So the question is duration of the flight is 1 hour. In ideal condition, duration of the flight is 1 hour. Option D is the right answer. So this method is by taking difference in speed, right? In the same way, you can consider difference in time duration. Since time duration difference is half an hour, right? So T2 minus T1 is equal to 30 minutes. Here T2 is nothing but, so time. So which is distance by speed. According to the formula, distance is 600 kilometers by speed. The respective speed is x minus 200, right? So due to bad weather, there is a reduction in the speed of the flight, right? Therefore, x minus 200 minus in ideal condition, the time is 600 by x is equal to 30 minutes. In terms of hour, it is half an hour. So on simplification, you will get some value of x, right? So in ideal condition, 600 by x gives the time duration of the flight. So you will get the same answer, which is 1 hour, right? Option D is the right answer. Question 22. Walking 6/7 of his usual speed, a man is 12 minutes too late. The usual time taken by him to cover that distance is. So here students, in an ideal condition, so man takes t time to cover some distance, right? So here we'll consider distance as d in ideal case, right? He covers d distance in t minutes of time, right? T minutes of time, he covers d kilometers or d meters, right? So here the time is in terms of minutes, right? T minutes of time. So that his speed is, right, x kilometer per minute, right? This is in ideal condition. But in actual condition, so he covers, what is the distance? The same distance, right? Here the distance is same, right? So he takes 12 minutes more time. A man is 12 minutes too late. Therefore, in actual condition, time becomes t plus 12 minutes, right? And his speed is 6/7 of his usual speed, 6 by 7 into x kilometer per minute. This is in ideal case, in actual case, right? In ideal case, speed is equal to x is equal to distance by time, d by t. In actual case, it is 6 by 7th of x is equal to distance by time is t plus 12, right? So here, substitute the value of x in this equation. We'll call it as equation 2, this as equation 1. Because we are going to find the usual time taken by him to cover that distance. We are going to find the time taken by him, right? So in usual time, that means in ideal case, what is the time taken by him to cover that distance? Therefore, we'll substitute the value of x, or we express the x in terms of time, right? Therefore, equation 2 becomes 6 by 7 into x is d by t is equal to d by t plus 12. So we can cancel d and d here. So we have 6 into t plus 12 is equal to 7t. 7 into t, right? Therefore, 6t plus 72 is equal to 7t. So 70 minus 60 is equal to 72, or t value is 72 minutes. So usual time taken by him to cover the distance d is 72 minutes, so which is nothing but 1 hour 12 minutes. It takes 1 hour 12 minutes to cover the distance in ideal case, right? In usual time. So option C is the right answer, right? So when you go for actual condition, to cover the same distance, he takes extra 12 minutes of time. So it becomes 1 hour 24 minutes, right? So 1 hour 24 minutes. So that the speed also changes, right? So if time is more, speed will be less, right? So speed becomes 6 by 7th of x, right? So therefore, for the given question, option C is the right answer. 1 hour 12 minutes is the answer. Question 23. Nilesh goes to school from his village at the speed of 4 km per hour and returns from school to village at the speed of 2 km per hour. If he takes 6 hours in all, then what is the distance between the village and the school? So here, if we take a distance between village and the school as d, right? And he goes to school from his village at the speed of 4 km per hour. His first speed was 4 km per hour, and while coming back, his speed was 2 km per hour. and totally he takes 6 minutes. So total time is equal to, so not 6 minutes, it's a 6 hours in all. So here we need to find the distance between village and the school. The value of D we need to find, right? For that, we'll consider time taken by him. So in first case, right, while going to school, let it be T1, and time taken by him while returning back, which is T2, right? Right, T1 plus T2 is the total time, right? Therefore, we'll consider the total time given is equal to 6 hours, which is already given, right? So which is nothing but T1 plus T2 is equal to 6, right? So what is T1 in terms of distance and speed? So T1 means time taken by him while going to school, right? So since speed is distance by time, time becomes distance by speed, right? Here distance is D, speed is 4 km per hour, right? Plus T2 is again the same distance by speed is equal to 6 hours. Total time is 6 hours. Here LCM is 4. The numerator becomes D plus 2D is equal to 6. Hence 3D is equal to 6 into 4, 24. Therefore, value of D becomes 24 by 3, which is 8 kilometers. Right? So distance between village and the school is 8 kilometers. Option A is the right answer. Question 24. A train starts at 7 a.m. from A towards B with a speed of 50 km per hour. Another train from B starts at 8 a.m. with a speed of 60 km per hour towards A. Both of them meet at 10 a.m. at C. The ratio between the distances AC to BC is. So here we'll consider 2 points A and B, or 2 places A and B, right? So one train starts at 7 a.m. from place A towards B with the speed of 50 kilometers per hour, right? Another train starts from B towards A at 8 a.m. 8 a.m. with the speed of 60 kilometer per hour, right? Both the trains meet at 10 a.m. So both the trains meet at 10 a.m. at some point, which is C. At point C, both the trains meet. So here we need the ratio between the distances AC and BC. So first we need the distances AC and BC, then we can find their ratio, right? What is distance AC? Distance AC is equal to, so here train A, or from place A, one train starts at 7 a.m., right? So it meets another train at 10 a.m. Here time duration is 3 hours. From A to C, time duration is 3 hours. And the speed is 50 km per hour. So distance AC is speed into time. By the formula, it is speed into time. So speed of first train is 50 km per hour into time. So in which it reaches point C is 3 hours. Therefore, distance between A to C is 150 kilometers. Whereas distance BC is again the same formula, speed into time. Here B to C, the second train starts from B, right? Therefore, its speed is 60 km per hour into, so time duration between 8 a.m. to 10 a.m. is 2 hours, right? 2 hours is the time duration here, right? From B to C, the time taken by the second train is 2 hours. Therefore, the distance becomes 120 kilometers. Here we need AC to BC ratio, right? 150 is to 120. So here it is 30 into 5 is 150, 30 into 4 is 120. So 5 is to 4 is the ratio, right? So AC to BC ratio is 5 is to 4. Option B is the right answer. Question 25. In the country of four, there are four cities named A, B, C, and D. B is to the east of A, C is to the south of B, D is to the west of C, and A is to the north of D. The government of four plan to connect these four cities by road such that it is possible for a person to go from one city to any one of the other cities. At the same time, the government wants to ensure that the total road length is minimum. The distances between A to B, B to C, C to D, and D to A are all equal to 10 kilometers. What should be the total length of the road? So here students, so we'll consider four cities A, B, C, and D, right? Such that B is to the east of A. To the east of A, we'll consider A is somewhere here. To the east of A means this direction, right? This is east direction. So B is to the east of A and C is to the south of D. So to the south means this direction, right? So C is to the south of B here and D is to the west of C. So west means this direction. This is west, right? D is to the west of C and A is to the north of D. North direction is this direction, right? The government of four plan to connect these four cities by road such that it is possible for a person to go from one city to any of the other cities, any of the other three cities, right? At the same time, the government wants to ensure that the total road length is minimum. So the total road length should be minimum. If you consider the road from place A or city A, the total road length from A to B, B to D, or anywhere if you take the length, it will be maximum, right? So the total road length should be minimum, right? And it is given that the distances between A to B is 10 kilometers, right? And B to C is also 10 kilometers. And C to D, it is 10 kilometers. And A to D is also 10 kilometers. Therefore, by joining these roads, we'll get a square, right? We'll get a square shape since the distances are same between the consecutive cities. So we'll get a square shape. Here, what should be the total length of the road? So by joining all the roads, the road length should be minimum. And from a particular place, so you can access all the cities. You can go to all the other cities, right? So only at this point, the middle point of the square, right? So the point through which the diagonal of the square passes through, right? Diagonal BD is passing through that point, and also the other diagonal AC is also passing through that point. Let the point be P here. From this place, all the cities are, right, in a minimum distance. The distance between P to B is minimum, right? A to P. So that the total length is minimum. You may consider this also. Why can't you consider the point Q somewhere here? So that Q to D distance will be minimum. But Q to other distances, other cities distances will be maximum. So that the total length becomes maximum. So you cannot consider some other place somewhere here, point Q, yes, right? Anywhere inside the square. You cannot consider those places, only at point P. So the P is a point at which two diagonals bisect each other, right? At P, AC and BD bisect each other. If you consider AP, BP, CP, and DP are the road lengths, sum of the lengths AP plus BP plus CP plus DP will be minimum. This is the minimum road length, right? Therefore, so we need to find what should be the total length of the road. So we need to find this value. For that, we'll consider whole diagonal AC and BD. Since AC is equal to BD, in a square, two diagonals are equal, right? AC is equal to BD. So we'll consider the triangle. In triangle ACD, AC is equal to, so square root of, by Pythagoras theorem, so diagonal is equal to root of sum of the squares of other two sides. So 10 square plus 10 square, right? So root of 100 plus 100 is 200, or you can consider it as 10 root 2 kilometer is length of AC, right? So we need the total length, right? AP plus BP plus CP. Since AP plus CP is AC, BP plus DP is BD, right? So total length of the diagonals, therefore total length of the road is equal to, so AC plus BD. So 10 root 2 plus 10 root 2, which is 20 root 2 kilometers. Since root 2 is 1.414, right? 414. You will get the answer as 1.414 into 20 as 28.28, which is nearly equal to 28.3 kilometers. This is the minimum road length, right? Possible minimum road length, right? From that point, from the point P, you can access all the cities, right? So therefore, so option C is the right answer. 28.3 kilometer is the minimum length of the, or total length of the road, right? Which is minimum. Question 26. A truck covers a distance of 368 km at a certain speed in 8 hours. How much time would a car take at an average speed, which is 18 km/h, more than that of the speed of the truck, to cover a distance which is 16 km more than that is traveled by the truck? So we'll consider a truck, right, which is moving with certain speed. So speed of the truck be x kilometer per hour, right? So it is x kilometer per hour, and it covers a distance of 368 kilometers in the time duration 8 hours. In the time duration 8 hours, it covers 368 kilometers. And here a car which is moving with the speed, so we'll consider a car moving with the speed which is 18 kilometer per hour more than that of the speed of the truck. So speed of the car is x plus 18 kilometer per hour, right? X plus 18 kilometer per hour to cover a distance which is 16 kilometer more than. So D is the distance covered by the car is 368 plus 16 kilometer more, right? Plus 16 kilometer. So here the question is, how much time would a car take to cover this much distance? What is the time taken by the car? We need to find, right? So for that, first we need speed of the truck, right? Depending upon the value of x, we can easily find the speed of the car here, right? So in first case, speed of the truck, which is x is equal to, speed is always distance by time, right? So 368 by 8, right? So 8 into 4, 32, 8 into 6. So 46 kilometer per hour is speed of the truck, right? So we need speed of the car, right? Therefore, speed of the car becomes x plus 18 kilometer per hour more, right? Therefore 46 plus 18, so which is 56 plus 8, 64 kilometer per hour is speed of the car, right? So with this speed, right, to cover 368 plus 16 kilometer distance, how much time does a car take, right? Therefore distance here is, distance to be covered is 368 plus 16 kilometer, which is 370, 368, 378, 384. 384 kilometer distance to be covered. Therefore, time taken time taken by the car is equal to distance by speed. So distance to be covered is 384 kilometer divided by its speed is 64 kilometer per hour. So 8 into 8 is 64, 8 into 4, then 8 into 8. So 48 by 8, again 8 into 6 is 48. Therefore, 6 hours is the time taken by the car, right? Time taken by the car to cover 384 kilometer distance with 64 kilometer per hour speed, right? Therefore, 6 hours is the answer. Look at the options. Option C is the right answer. Question 27. Bob is twice as fast as Deepak and Era is thrice as fast as Deepak. If Era travels at certain distance in 20 minutes, find the time taken by Bob to cover the same distance. So here, Bob is twice as fast as Deepak means speed of Bob. Speed of Bob, if you consider it as SB, speed of Bob is equal to twice as fast as Deepak means 2 times speed of Deepak. Speed of Deepak. Right? Therefore, you can write 2 times speed of Deepak, 2 times SD. Right? And speed of Era is thrice as fast as Deepak. So we'll consider speed of Era. Speed of Era as SE is equal to 3 times speed of Deepak. SD, 3 times SD. Right? If Era travels at certain distance in 20 minutes, so time taken by Era is equal to T, you can consider that TE as 20 minutes. Find the time taken by Bob. So time taken by Bob, which is TB, to cover the same distance. To cover the same distance means both Bob and Era will be covering same distance D. Both of them are covering same distance. Therefore, let us find distance covered by Era first. Right? Distance covered by Era first. Therefore, distance covered by Era, so we call it as DE, is equal to, distance is always speed into time, right? Therefore, speed of Era into time taken by her, right? Therefore, DE, distance traveled by Era, is equal to, speed of Era is 3 times speed of Deepak into time taken by her is 20 minutes. Right? Here, what is asked in the question? Time taken by Bob to cover the same distance. Come back to this case. Time taken by Bob, TB, is equal to, according to the formula, time is distance covered by him, distance covered by Bob divided by speed of Bob. Right? Time is distance by speed. So distance covered by Bob is nothing but distance covered by Era. Right? Both of them are covering same distance. Therefore, dB can be written as dE, right? dB can be written as distance covered by Era, right? Distance by Era divided by SB. SB means speed of Bob, which is 2 times speed of Deepak. Because why we are writing 2 times speed of Deepak in place of SB? Because distance covered by Era is in terms of SD, right? So distance covered by Era is 3 times speed of Deepak into 20 divided by 2 times speed of Deepak. So you can cancel speed of Deepak and speed of Deepak, SD and SD. 2 into 10 is 20. So 10 into 3 is 30 minutes is time taken by Bob to cover the same distance. Right? Option B is the right answer. Right? This is how we are calculating time taken by Bob. Right? Based on speed of Bob, Era and Deepak and their relation. So we can easily find such type of questions, students. So for the given questions, option B is the right answer. Question 28. A thief steals a car at 2:30 p.m. and drives it at 60 km per hour. The theft is discovered at 3 p.m. and the owner sets off in another car at 75 km per hour. When will he overtake the thief? Here, students, thief steals a car. So we'll consider thief. He steals a car at 2:30 p.m. and he drives at the speed of 60 km per hour. And the theft is discovered at 3 p.m. and the owner starts chasing the thief at 3 p.m. Right? So we'll consider owner and he starts chasing the thief at 3 p.m. and both of them are moving in the same direction. Right? And owner is moving with the speed of 75 km per hour. So when will he overtake the thief? That means the time at which the owner overtakes the thief should be calculated, right? Therefore, so here we are using the concept of relative speed, right? So to solve such type of questions, we can use two methods. So one is using the concept of relative speed, right? So another method I'll explain later. So here in method one, we use the concept of relative speed. Relative speed is nothing but the when two bodies or two persons are moving in the same direction, or it may be in different directions with two different speeds. The speed of one body with respect to another is called relative speed, right? So relative speed is nothing but speed of one body or one person with respect to another is called relative speed. It may be the case in which two bodies are moving in the same direction, or if two bodies are moving in the different direction, right? In both the cases, the relative speed is applicable, right? In the given case, in the given question, two persons are moving in the same direction, right? Therefore, relative speed here, when will he overtake the thief is asked. When will the owner overtake the thief? Right? For that, the relative speed of the owner with respect to the thief is nothing but according to the concept distance covered by them, because both of them have covered the same distance, divided by time taken by the owner. Right? Here, relative speed is nothing but difference in their speeds. So 75 minus 60 km per hour is equal to, so distance covered by them. What is the distance covered by them? So for that, we use here the case of thief, right? So he started at 2:30 p.m., right? So by 3 p.m., he covers some distance, right? Distance covered by them will be, distance is always speed into time, right? So speed of thief into time taken by him to cover that distance divided by time taken by the owner. Right? Here the difference in their speed, LHS part is 15 km per hour. Speed of the thief is already given 60 into from 2:30 to 3 p.m. So by 3 p.m. he covers some distance, means he takes half an hour, right, to cover that distance. So 60 by 2, which is 30 becomes, and time taken by the owner, let it be T, right? Therefore, T becomes 60 by 2 is 30 by 15, right? T becomes 2 hours. Therefore, here the time will be 2 hours. That means owner takes 2 hours of time to catch the thief or to overtake the thief, right? So at 3 p.m. if he starts, if he takes 2 hours, means by 5 p.m. he catches the thief or he overtakes the thief. Therefore, he overtakes the thief at 5 p.m. Option B is the right answer, right? So here we'll consider another method. Method 2. Method 2 is, so we'll consider time taken by the thief, right, to reach some distance. So let distance covered by them be x kilometers. right? So thief and the owner, both of them have covered X kilometers, for example, right? To cover that distance, what is time taken by the thief? Time T1 we'll consider, right? Time taken by the thief will be, according to the concept, time is equal to distance by speed. Speed of the thief is 60 kilometer per hour. X by 60 is time taken by him, right? Whereas time taken by the owner is half an hour less than time taken by the thief. Therefore, T2 is equal to T1 minus half an hour, right? Therefore, T1 minus half, T1 T1 minus half an hour becomes same distance covered by the owner divided by his speed, right? So distance by speed is 75, right? I'll mention distance and speed for your better understanding, right? Therefore, here T1 T1 becomes, so how when will he overtake the thief? The question is, when will he overtake the thief? T1 becomes X by 75 plus half an hour, right? Right? Whereas T1 is X by 60. In another case, X by 75 plus half an hour, right? How do you find T1 in this example now, in this method, second method? So here we can equate both the sides, right? X by 60 is equal to X by 75 plus half an hour, right? So let's find the value of X first, right? Now X by 60 minus the X by 75 is equal to 1 by 2. So 75 minus 6 is 15X is equal to 60 into 75 by 2, right? Therefore, value of X becomes 60 into 75 by 2 into 15. So 15 into 4 and 2 into 2. So 75 into 2 becomes 150, right? Here 150 kilometers, right? So X is nothing but distance covered by them is 150 kilometers. To cover that distance with 75 kilometer per hour speed, right? So we are considering the case of owner. So here distance is 150 kilometer. He is moving with the speed of 75 kilometer per hour. Therefore, time taken by him will be distance by speed. So 150 by 75, which is equal to 2 hours. So owner takes 2 hours of time. So he has started at 3 p.m. 3 p.m. plus 2 hours means he will catch the thief or he will overtake the thief at 5 p.m. Right? Compared to the second method, first method is very easy considering the relative speed concept. So very easy concept. So option B is the right answer. Question 29. Starting from a point at a speed of 4 km per hour, a man reaches at a certain place and returns back to the point where he had started journey on bicycle at the speed of 16 km per hour. His average speed during the entire journey will be. So here students will consider two places A and B. From place A, from point A, man starts his journey with the speed of 4 km per hour and he reaches the place B. And he returns to the same place. He returns to his starting point A again with different speed, which is 16 km per hour. Right? Here, same man has two different speeds. So in such a case, average speed is calculated using the formula average speed, right? When same object or same person has two different speeds, right? And the same object or same person is coming back to his original place. In such a case, average speed is 2 times product of his two different speeds. So if you consider X as his first speed and Y as his final speed, so it becomes 2 into XY divided by sum of his speeds, X plus Y. Therefore, 2 times X is 4 km per hour into 16 km per hour divided by 4 plus 16. Therefore, it is 8 into 16 by 20, right? So 4 into 4, 4 into 5. So which is 32 by 5. So 6.4, right? Kilometer per hour is his average speed. Option A is the right answer. In such type of questions, when same object or when a single person has two different speeds, in such a case, we use the concept of average speed, which is equal to 2 times the product of his two different speeds divided by sum of his speeds, right? For the given question, 6.4 kilometer per hour is the answer. Option A. Question number 30. Excluding stoppages, the speed of a bus is 54 km per hour and including stoppages, it is 45 km per hour. For how many minutes does the bus stop per hour? Before going to bus stop per hour, right? So we have to find the time spent on stoppages. What is the time spent on stoppages? Right? So depending on that, so we can find the time, right? How many minutes does the bus stop per hour, right? First, we need to find the time spent on stoppages, right? For that, so we have to find time spent excluding stoppages and including stoppages, right? Since we are using the concept of speed here, which is equal to distance by time, distance traveled by time. Therefore, time is equal to distance by speed, right? So, to travel from one place to another place, right? Maybe from home to school. So, excluding stoppages, speed of the bus is 54 km per hour. So, we'll consider excluding stoppages and including stoppages separately, right? Including stoppages. Here, excluding stoppages, speed is 54 km per hour. Let the distance be x kilometer. Distance between two places be x kilometer, right? Therefore, here distance is equal to x kilometer. Therefore, time spent excluding stoppages. So, time is distance by speed. Therefore, it is x by 54. Here, including stoppages. So, here the speed is 45 kilometer per hour, right? Kilometer per hour, and the distance is x kilometer. Therefore, time spent here is x by 45 r in terms of hours, right? Right? Here first we need to find time spent on stoppages, right? For that, we need what is the relation between time spent excluding stoppages and including stoppages, right? So for that, how many times more, right? When the time is excluding stoppages, right? How many times it is more than time spent including stoppages. Therefore, whether it is more or less, that also should be taken. Therefore, we'll consider time spent excluding stoppages as T1, including stoppages as T2, right? Therefore, T1 by T2 gives x by 54, right? Divided by x by 45. So 45 goes to numerator, x and x will get cancelled. We have 45 by 54. So 9 into 5, 9 into 6, right? T1 by T2 is 5 by 6, right? That means T1 is time spent excluding stoppages, right? So which is including stoppages. That means including stoppages means more time taken. This, right? How much more time taken for including stoppages? 1 hour more time taken, right? Therefore, that 1 hour is a time spent on stoppages. Therefore, time spent on stoppages is equal to, here 6 time spent excluding stoppages minus time spent including stoppages, which is 1 hour. 1 hour time was spent on stoppages. Now come back to the question, right? So how many minutes does the bus stop per hour? Per hour means in 60 minutes, right? So out of 60 minutes, how many minutes does the bus stop, right? So here here students, for 6 hours. So here excluding stoppages is more time out of 6 hours. So for example, bus is traveling from A to B. It takes 6 hours of time, right? Not excluding. So it including, right? Including stoppages here because it takes more time, right? So it takes 6 hours of time. In that, 1 hour of time is taken for stoppages, right? Time spent on stoppages 1 hour, right? Therefore, in yes, per hour bus stop, how many minutes does the bus stop per hour, right? So in 1 hour, how many minutes for stoppages, right? Therefore, so out of 6 hours, right? 1 hour for stoppages. Stoppages. Therefore, out of 1 hour, 1 hour. So which is equal to out of 6, 1 hour is for stoppages. Therefore, for 1 hour. So which is 1/6 hour is for stoppages. 1/6 hour means 1/6 part of an hour. How many minutes? 60/6, which is 10 minutes. Right? So in 1 hour, so the time spent on stoppages is 10 minutes, right? Therefore, option C is the right answer, right? So 10 minutes, for 10 minutes, the bus stops per hour, right? Therefore, option C is the right answer. Students, if you want to practice such questions, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. Question 31. The hometown of Rekha and Radhika are 600 kilometers apart. They both started moving towards each other at a speed of 80 km per hour and 70 km per hour and crossed each other at Sundarnagar. What is the ratio between Rekha's hometown to Sundarnagar and Sundarnagar to Radhika's hometown? So we'll consider two places, right? So Rekha's hometown. So we'll call it as A, right? And Radhika's hometown as B, right? So the distance between A to B is 600 kilometers, right? 600 kilometers. So they started moving towards each other at two different speeds, 80 kilometer per hour and 70 kilometer per hour respectively. And they crossed each other at some other place. So somewhere here at Sundarnagar, right? At Sundarnagar. Let it be C, right? So here we need the ratio of distance between Rekha's hometown to Sundarnagar. Ratio of Rekha's hometown to Sundarnagar is AC distance is to Sundarnagar to Radhika's hometown. So AC is to BC distance, right? So for that, here we are using the concept of speed, which is equal to distance by time. Distance traveled by time, right? Here we need the distances AC and BC, right? Here Rekha is moving with some speed, right? And she takes T time. Time is T here to reach Sundarnagar. At the same time, Radhika is moving with 70 km per hour speed. And she also takes same time to reach Sundarnagar, right? Therefore, here time is T. Time is same. Time is same. Therefore, distance AC is equal. Distance is speed into time, right? So speed into time. So AC distance has been covered by Rekha, not Radhika. AC, this distance has been covered by Rekha with the speed 80 km per hour, right? So 80 km per hour, and she takes T time, right? T hours of time. Whereas BC distance has been covered by Radhika with 70 km per hour, right? In T time. Therefore, AC is to BC is equal to ATT divided by 70T. T and T will get cancelled. So we have 10 into 8, 10 into 7. 8 by 7 or 8 is to 7 is the required ratio. Right? Therefore, 8 is to 7. Option C is the right answer. Question 32. A farmer traveled a distance of 61 km in 9 hours. He traveled partly on foot at the rate of 4 km per hour and partly on bicycle at the rate of 9 km per hour. What is the distance traveled on foot? Here, total distance to be traveled is 61 km, right? So total distance is 61 km. He can travel this much distance in 9 hours. Right, total time taken is 9 hours, and the total distance to be traveled is 61 kilometer. So in that, he traveled partly on foot at the rate of 4 kilometer per hour. That means, say for example, distance traveled on foot with the speed 4 kilometer per hour be x kilometers, right? So whereas the remaining distance will be 61 minus x kilometers will be traveled on bicycle. This much distance will be traveled on bicycle. So at the rate means with the speed 9 kilometer per hour. Here we need the distance traveled on foot. Distance traveled on foot means the value of x. So we'll consider T1 and T2 be the time taken by him in two different situations, right? So here T1 is time taken to travel on foot. We know the formula for speed is equal to distance by time, right? Therefore, time becomes distance by speed. Here, T1 is the first. In first situation, time taken by him is distance x kilometer by speed is 4, whereas T2 is distance which is remaining distance 61 minus x by 9. So, we'll consider T1 plus T2. So, total time taken by him will be x by 4 plus 61 minus x by 9. Here T1 plus T2 is the total time, which is 9 hours, is equal to, since LCM is 36, numerator becomes 9x plus 61 minus x into 4 is 61 into 4 is 244 minus 4x, right? So we have 9 into 36 is equal to 5x plus 244. 9 into 36 becomes 54. 324 minus 244 gives 5x. So we have 80 is equal to 5x. Therefore, the value of x becomes 80 by 5, which is 16. Right? Here 16 kilometer is the distance traveled by him on foot. 16 kilometer, value of x. Hence, option B is the right answer. Question number 33. P, R and S. Here is a small correction. So, P, R and S are three collinear places where A, B and C lies respectively. So, here students, three persons A, B and C lie in three different places, P, R and S respectively, right? A used to travel to R at a speed of 120 km per hour and takes 4 hours. On a particular day, B and A both start moving towards S at the same time and A crossed B in 6 hours. Find the speed at which B was traveling. So students will consider three places P, R and S. P, R and S, right? Where three persons A, B and C live, right? So here A used to travel to R. So that means A is traveling towards R, right? At a speed of 120 km per hour. So here speed of A is 120 km per hour, right? A's speed, right? And A takes 4 hours of time. So time taken by A is 4 hours. Right? On a particular day, B and A both start moving towards S. So B and A are moving in the same direction, right? So towards S. Here, let us assume speed of B as x kilometer per hour, right? Here A and B both are moving in the same direction with two different speeds, right? So now both start moving towards S at the same time, and A crossed B in 6 hours. So here, so somewhere here, let this point be P somewhere here, right? A crossed B in 6 hours. Let this point be P, right? To reach point P, A takes 6 hours of time, and also B takes 6 hours of time, so that they meet each other, right? A crossed B in 6 hours. So find speed at which B was traveling. So we have to find the value of X, B's speed, right? Here we know that speed can be expressed in terms of distance and time. Speed is distance by time, right? So here we will express the distance in terms of speed and time, so that we can easily find B's speed, right? So distance traveled by A to reach P, right? So we'll consider, so distance traveled by A to reach P, point P, where A meets or A crosses B, right? To reach P is distance is speed into time. A's speed is 120 and A takes 6 hours of time. Here A is taking 6 hours of time, right? Not 4 hours. 4 hours time is taken to reach R, here, which is given, right? So this duration is 4 hours. Right? To reach P, A takes 6 hours of time. Therefore, distance traveled by A is 720 kilometers, right? Whereas distance traveled by B, distance traveled by B to reach P is moving with the speed of X kilometer per hour, and B also takes 6 hours of time. Therefore, it is 6x kilometer. 6x kilometer is distance traveled by B. So this whole distance AP minus BP, right? Distance traveled by A to P minus BP gives AB distance, right? Therefore, AP minus B to P is AB distance, right? What is AB distance? It is given already, right? A is moving with the speed of 120 kilometer hour and takes 4 hours to reach R, to reach B, right? AB distance is A's speed, which is 120 kilometer per hour, into 4 hours, right? Speed into time taken, whereas AP is 720 kilometer minus BP is 6x. Now we can easily find the value of X. Therefore, 720 minus 120 into 4 is 480 is equal to 6x, right? Therefore, 6x is equal to 720 minus 480 is 240, right? 240. Therefore, value of X is 40, right? 40 kilometer per hour. What is X? Speed of B, right? Speed of B is 40 kilometer per hour. Option A is the right answer. Question 34. A and B start walking at the same time on a circular path with circumference. Here it is 35 kilometer. It is not 35 meter. Circumference is 35 kilometer. If they walk in the same direction at 4 kilometer per hour and 5 kilometer per hour respectively, after what time will they meet together? So we'll consider a circular path like this, right? So A and B start walking at the same time on a circular path with two different speeds, right? 4 kilometer per hour and 5 kilometer per hour, right? And circumference of the circular path is 35 kilometer. 35 kilometer is the circumference. That means if they start from this point, right, to complete one round means the distance traveled to complete one round will be 35 kilometer, right? So after what time they'll meet together, right? Here, when two bodies are moving with two different speeds, two bodies are moving with two different speeds, we use the term relative speed. Relative speed. Right? They may be moving in the same direction or in different directions. So relative speed is applicable. When two bodies are moving in the same direction, the difference in their speeds, difference in their speeds is considered as their relative speed. When they are moving in the opposite direction, then sum of their speeds is considered as their relative speed. Right? Here, persons A and B, two persons are walking in the same direction. Right? On a circular path, they are walking in the same direction. Therefore, their relative speed is equal to, according to the concept, difference in their speed, which is 5 kilometer per hour minus 4 kilometer per hour is equal to, according to the general formula for speed is always distance by time, right? So distance by time. Here relative speed in general terms, we can define it as speed of one body with respect to another body, right? Here speed of the body which has the highest speed, which is B, speed of B with respect to A, right, is equal to, so in order to cover one round, B has to travel 35 kilometer distance in T time. Therefore, speed of B with respect to A is 35 kilometer by time taken by it, right? Therefore, relative speed is equal to 35 kilometer by time taken by B, right, to cover that. So here relative speed is 1 kilometer per hour is equal to 35 kilometer by T. Hence T is equal to 35 by 1 is 35 and the unit is hours, right? So after 35 hours, A and B meet together, right? Here T is nothing but after how many hours? 35 hours. 35 hours, they'll meet together. Hence, option A is the right answer. Question 35. P travels for 6 hours at the rate of 5 km per hour and 3 hours at the rate of 6 km per hour. The average speed of the journey in kilometer per hour is. Here we know the formula for average speed. It is always average speed is equal to total distance traveled by total time taken, right? Total distance traveled by total time taken. Here, P travels for 6 hours, right? So, for the first 6 hours, P travels with the speed of 5 km per hour. So, at the rate of 5 km per hour means with the speed 5 km per hour. And 3 hours at the rate of 6 km per hour with the speed 6 km per hour. So here we need average speed of the journey, right? To find average speed, we need total distance, right? In first 6 hours, what is the distance traveled by P? So distance D1 we need to find, right? Whereas in the last 3 hours, what is the distance? Let it be D2, right? Using the speed formula, speed is distance by time. Therefore, distance is speed into time, right? Distance is speed into time. Therefore, distance traveled by P in 6 hours is speed is 5 km per hour into time is 6 hours. Hence, P travels 30 kilometers distance, right? In the last 3 hours, P travels 6 into 3, which is 18 kilometer distance. Hence, total distance traveled will be 30 plus 18 kilometer and total time is 6 plus 3 hours. Therefore, 48 by 9 is the average speed. So, 5 integer, 9 into 5, 45. 9 integer, 3 by 9, right? Kilometer per hour is the average speed. Still, you can simplify. 5 integer, 3 by 9 means 1 by 3 kilometer per hour is the average speed of P. Hence, option B is the right answer. So, to find average speed, we need total distance, right? And we have two different situations here. So, in first 6 hours, what is the distance traveled by P? We need to find first. And in the next 3 hours, what is the distance traveled by P? Then we'll take total distance and total time, 6 plus 3 hours. You'll get the answer. Hence, option B is the right answer. Question 36. Samir is traveling on his cycle and has calculated to reach point A at 2 p.m. if he travels at a 10 km per hour speed. And he will reach there at 12 noon if he travels at 15 km per hour. At what speed must he travel to reach point A at 1 p.m.? So students, we'll consider Samir's starting point somewhere here, right? So he's traveling on his cycle and he will reach point A at 2 p.m. At 2 p.m. he will reach point A, right? So let X be the distance, right? Or D be the distance. Anything you can consider. So let D be the distance between his starting point to place A, right? From P to A you can consider, right? If he travels with the speed 10 km per hour, then only he can reach the place A at 2 p.m., right? So he will reach the same place at 12 noon if his speed is 15 km per hour. In the second scenario, if speed, I'm taking all speeds here in the left part, right? So 15 km per hour, if he travels with that speed, he will reach the same place A at 12 noon. Here the question is, so at what speed must he travel to reach at A at 1 p.m.? So in the third scenario, what should be the speed if he reaches the same place at 1 p.m.? Right? For that, we need the distance between two places D and also time taken in two different scenario, right? Then only you can find the speed in the third case, right? So here we'll consider the first scenario, right? He is traveling with 10 kilometer per hour speed and he reaches at 2 p.m., right? So let T be the time taken by him. In the first scenario, let T be the time taken by him to reach A, right? In the second case, right, he reaches the same place at 12 noon with higher speed. That means he takes 2 hours lesser time, right? Therefore, time taken by him will be T minus 2 hours, right? Time taken by him in the second scenario will be T minus 2 hours, right? So we'll consider these two distances and time, right? So here distance will be same, right? Therefore, distance traveled, so here it is equal to D. According to the formula, distance is speed into time, right? Speed into time. In the first scenario, speed is 10 km per hour and the time is T hours. Hence, distance will be 10 T kilometers, right? Whereas in the second scenario, distance traveled, distance is same here. D is equal to speed into time. Speed is 15 km per hour into T minus 2 kilometers. Speed into time. Therefore, we can equate 10T and 15 into T minus 2. Since the distances are same, right? Therefore, 15T minus 10T is equal to 30, right? Therefore, so 5T is equal to 30. Therefore, T is equal to 6 hours, right? So with 10 km per hour, he takes 6 hours. 6 hours time to reach A. With 15 km per hour speed, he takes 6 minus 2 means 4 hours time to reach A. Here the question is, so at what speed he must travel to reach A at 1 p.m. So if he takes 6 hours of time from P to A with 10 km per hour speed, he should start at what time he should start? So 2 p.m. minus 6 hours gives how much? 8 a.m. right? Therefore 2 p.m. 2 p.m. minus 6 hours is equal to 8 a.m. Right? Therefore, so he must start his journey from point P at 8 a.m. in the first scenario. Right? So here at what speed he must travel to reach point A? So speed is equal to speed in the third scenario. Speed is distance by time. Distance by time. So what is the distance? We'll calculate the distance. So using the first case, distance traveled D is 10 into T. We know the value of T, which is 6 hours. Therefore, distance between P and A, two places. Distance D is equal to 10 into T. So 10 into 6 is equal to 60 kilometers is the distance. Therefore, speed becomes 60 kilometers divided by. Here, what is the time? So time from 8 a.m. to 1 p.m. Right? So 8 a.m. to 1 p.m. becomes 5 hours. Right? So in the third scenario, I'll consider third scenario here. So time from 8 a.m. to 1 p.m. becomes 5 hours. Right? So 8 a.m. to 1 p.m. which is equal to 5 hours. Therefore, 60 by 5 becomes 12 kilometer per hour is his new speed, right? So that he can reach that particular point at 1 p.m. Hence, option B is the right answer. Question 37. How long will a boy take to run round a square field of side 35 meters if he runs at the rate of 9 kilometer per hour? So we'll consider a square field of side 35 meters. 35 meters, right? So a boy starts from some point, some corner point P, right? So if in order to complete one round, right? In order to complete one round means he has to cover the sides of the square field, right? 35 plus 35 plus 35 plus 35. In order to complete one round with 9 kilometer per hour speed, so what is the time taken by him? Time taken by him, right? Here the distance traveled will be distance traveled D will be 35 into 4. There are 4 sides, right? Equal sides. 35 into 4 gives 140 meters. Is the total distance to be traveled by that boy, right? And his speed S will be 9 kilometer per hour. Here the speed is in terms of kilometer per hour. Better to express in terms of meter per second. Since the options are in terms of seconds, so 9 into 1000 meter divided by 1 hour. 1 hour means 3600 seconds. Right? Therefore, so how long will a boy take to run around that square field? How long means what is the time taken by him? Therefore, time taken by him will be, since speed is distance by time, time will be distance by speed, D by S, right? So distance is 140 meters by speed is 9 into 1000 divided by 3600. So denominator of the denominator will go to numerator. You can cancel 2 zeros, 9 into 4, 36, 10 into 14, 56 seconds. Time taken by that boy to cover one complete round, right? To cover one complete round of the square field is 56 seconds. Hence, option A is the right answer. Question 38. A, B and C cover an equal distance at a speed of 36 km per hour, 54 km per hour and 72 km per hour respectively. Find the time taken by A, B and C respectively if together they take 9 hours of time. right? Here we'll consider the speeds. So speed with which A is moving is 36 kilometer per hour, and A covers some distance D, whereas B covers the same distance D with 54 kilometer per hour. Whereas C also covers the same distance D with 72 kilometers per hour, right? So we know that speed is equal to distance by time. Distance by time, that means speed is inversely proportional to time, right? Here, three speeds have been given, right? These speeds are in the ratio 2 is to 3 is to 4. So 18 into 2, 18 into 3, 18 into 4, right? So ratio of speeds is equal to 2 is to 3 is to 4. Right? 18 into 2 is 36 kilometer. Then into 3 is 54, into 4 is 72 kilometer per hour. Right? Here what is asked? Find the time taken by A, B and C. Individual time taken by A, B and C. So the times will T1, T2 and T3. Right? Since time is inversely proportional to speed, or speed is inversely proportional to time, so speed is inversely proportional to time. Therefore, the ratio of speeds is inversely proportional to the time, right? Therefore, ratio of time taken by ABC, taken by A, B and C, individual times. The ratio will be 4 is to 3 is to 2. The simplest method to find the time taken by them, right? So here we'll directly consider it as 4 hours, 3 hours and 2 hours, right? Since the total time is 9 hours, if together they take 9 hours of time, right? Directly we'll take 4, 3 and 2 hours, because 4 plus 3, 7 plus 2 becomes 9 hours, right? Since the time ratio is 4 is to 3 is to 2, no need to go for multiples of 4, 3 and 2 here. Directly we can add 4 hours plus 3 hours plus 2 hours, which becomes 9 hours. Right? Hence option B is the right answer. Question 39. A person travels from P to Q at a speed of 40 km per hour and returns by increasing his speed by 50%. Find his average speed for both the trips. Here a person is moving with some speed which is 40 km per hour and he reaches point Q, and he comes back with a different speed. He comes back to the same position P with different speed, means by increasing his speed by 50%. 50% of 40 is 20 km per hour, and increase in speed is 20, and his new speed will be 60 km per hour. Right? So what is the average speed? Right? Here when a body has two different speeds, right, we use the concept of average speed, right? Here average speed when a body comes back to its original position, right? Here P goes to Q and it comes back, that person comes back to P, position P only. In that case, average speed is equal to 2 times the product of his speeds. X and Y are his speeds divided by sum of his speeds. I'll repeat once again. When a body has some speed, is moving to some position, while returning back to the same position when it has different speed, right, like 60 km per hour, right? In that case, we use average speed, which is equal to 2 times the product of his two different speeds divided by sum of the speeds, right? Here X is 40, Y is 60 km per hour. Substitute the values. 2 times 40 into 60 by 40 plus 60. Therefore, 2 times 60 into 40 by 100. So we have 2 into 50 as 100. So 2400 by 50. So we have 5 into 4 and 5 into 8. right? So his average speed will be 48 kilometer per hour. Hence option B is the right answer. Question number 40. A salesman travels a distance of 50 km in 2 hours 30 minutes. How faster in kilometer per hour on an average must he travel to make such a trip in 5 by 6 or less time? So here students, a salesman travels a distance of 50 km. Here D is 50 km distance in time 2 hours 30 minutes. 2 hours 30 minutes means 2.5 hours. So which is nothing but 5 by 2 hours. Right? In 5 by 2 hours, he travels a distance of 50 km. Here the question is, to travel the same distance, if the time is 5 by 6 hour less time, so compared to the previous time, in the second case, if the time is 5 by 6 hour less time means 5 by 2 minus 5 by 6 of an hour, of 1 hour. Right? So to travel the same distance, so 50 kilometer, how much faster means, so what will be the speed and how much the speed should be increased, right? We need the increased speed or increase in speed. Increase in speed we need, right? To find increase in speed, we need the original speed and the final speed, right? Speed in the second scenario. So speed in the first scenario is, so in first case, speed is distance by time by the formula. Distance is 50 km, time is 5 by 2. So this 2 goes to numerator. So distance will be 20 km, right? Sorry, speed is 20 km per hour, right? Speed is 20 km per hour, right? So in the second case, is time is, if time is different, right? Time is 5 by 6 or less time. That is original time minus 5 by 6 gives, so 10 by 6 hour, right? 5 by 2 minus 5 by 6. 6 is LCM. So 15 minus 5 is, yes, 10 by 6 of an hour. Right? 10 by 6 hour. Then speed becomes again distance by time. Distance is 50 km, which is same, by 10 by 6. So this by 6 will go to numerator. So it becomes 30 km per hour. New speed will be 30 km per hour. So increase in speed will be 30 minus original speed was 20 km per hour. So speed of, or he must increase his speed 10 kilometer per hour, right? So how faster he must go? He must go 10 kilometer per hour faster compared to his original speed. Hence option D is the right answer, right? Option D is the right answer. With this, I am completing this paper. Students, if you want to practice such questions on time and distance, please visit our website www.examsnet.com. You can also download our app. The link is given in the description box. I wish you all the very best for your future exams.